Roller Coasters, Why We Need Algebra 1 by Sarah Johnson.
Okay, so today we're going to talk about roller coasters, which are pretty fun. And my favorite part are going up and down in a straight line and over the hills. Okay, so in math, we call going straight up and down in a line a linear function. It's linear because it's in a line, and it's a function because if you do the vertical line test, which is basically making a vertical line through any point on the line, and it should not cross a point twice. This means that this would be a linear function, and this would not. So, this part of a roller coaster would be a linear function, but a loop would not because it's not linear, and it's also not a function. Okay, so there's two ways a linear function can be displayed. It could be discrete, or it could be continuous. Discrete would be like the people's heads on a roller coaster, versus continuous would be like the tracks on a roller coaster. See? Points, line, discrete, continuous. Okay, so there's a huge difference between a real roller coaster and a kiddie roller coaster. The real roller coaster goes so much faster. One reason for this is because it's so much steeper than the kiddie roller coaster. In math, we call the difference between this slope. Slope is rise over run. We would say that the real roller coaster has a much steeper slope than the kiddie roller coaster. Okay, let's say this is the real roller coaster and this is the kiddie coaster. The formula for slope is y2 minus y1 over x2 minus x1. If we want to find the slope of the real roller coaster, we would do 7 minus 5 over 2 minus 1 to get the slope of 2. If we want to find the slope of the kiddie coaster, we would do 5 minus 4 over 5 minus 1 to get the slope of 1/4. Since 2 is a lot bigger than 1, we can obviously see that the real roller coaster has a much steeper slope than the kiddie coaster. Okay, so one of the most important parts about linear equations is determining their actual equation. There's three ways you can write a linear equation. 1. Point slope. Y minus y1 equals mx minus x1. You're going to leave the x and the y alone, but you're going to change the m and the y1 and the yx2. 1. Second way. Point slope intercept. Y equals mx plus b. M is the slope and b is the y-intercept. The third way is standard. This is a bit confusing, but it's really simple once you get it. Ax plus by equals c. Your a, b, and c must all be whole numbers, and a and b must also not be equal to 0. Also, a must be positive. So, we're going to find the point slope equation for this line. Remember, we're going to change y1, m, and x1. So, m is the slope, the formula for slope is y2 minus y1 over x2 minus x1. So, we're going to use the points 260 and 050 for this. If we use points 260 as 2 and 050 as 1, we substitute them in for this formula, we get 10 over 2, which translates to 5. So, we put 5 as our slope, and then we're going to do we're going to use 260 for this equation. So we're going to do y minus 60, because that's the y variable, equals 5x minus 2, because that's the x variable. Pretty simple, right? We're going to find the slope-intercept form of this line. Remember, slope-intercept is y equals mx plus b. M is slope, and we have already found slope to equal 5. B is the point at which the line will intercept the y-axis. For this problem, let's pretend the y-axis is a support beam and the x-axis is the ground on the roller coaster. So, we can already find the slope-intercept equation of this line, since the y-intercept is quite obviously at 50. So, the slope-intercept equation for this line would be y equals 5x plus 50. However, sometimes it's going to be less obvious, and the slope-intercept will be in between two numbers. In order to find the slope-intercept form, you would start off by using the point-slope form. Y minus y1 equals mx minus x1. So, slope is equal to 5, and we never change y and x. So, this is going to be the point-slope form if we use the coordinates 2, 60. So, remember, it's y minus y1 and x minus x2. So, you're going to subtract the numbers. So, it's going to be y minus 60 equals, and we're going to use the distributive property to find this equation, to solve this and simplify it. So, it's going to be 5x minus 10. In order to find slope-intercept form, remember it's just y by itself, so we want to move the 60 over here. You do this by adding 60, because remember, minus 60 plus 60 is going to equal 0. However, since we added it to this side, we also must add it to this side. So we're going to add 60 to this side as well. So that means that our slope-intercept form is going to be y equals 5x plus 50. Hey, look, they're the same. Remember, standard is ax plus by equals c. A, b, and c must all be whole numbers, and a and b cannot both be 0. Also, a has to be positive. So, I've already figured out the point-slope form and the slope-intercept form. We're going to start with, we're going to use the slope-intercept form to figure out the standard form. So, y equals 5x plus 50. We want to get a over to this side because that's what it says in the equation. So, if we subtract 5x and add it and subtract it from this side, which is the subtraction property, then we get negative 5x plus y equals 50. However, 5x is negative, so since we need it to be positive, we're going to multiply the entire thing by negative 1. This means that 5x will now become positive. However, y will become negative and 50 will also become negative. This is going to be your standard equation. Remember, it's only a that has to be positive, and it is, so we're good on that. And then all these are whole numbers, so we're good with that. And then neither a nor b is 0, so we're good. This is the correct standard equation for this line. Okay, one more thing about linear equations. So you know how they're in a roller coaster, sometimes it looks like two tracks are overlapping because there's one in the foreground and one in the background like this? Well, in math we call this a system of equations because there's two equations. When we want to solve this system of equations, we're basically trying to find the point at which the two lines will overlap. So, there's 3 ways we can solve this. The first is graphing. Basically, you're going to graph the two lines and see what point they cross at, which is great until the point at which they match up at isn't a perfect whole number. Another way that we do this is called substitution, which works great if one of the equations is y equals mx plus b. Basically, you're going to substitute y in a standard equation for mx plus b. The third way is elimination. Basically, you're going to stack the two equations up and add them. It works specifically for us two standard equations. However, you're going to try and eliminate either all the x's or all the y's. And then you can solve for the other number that you didn't eliminate and get the answer. Now this is how you do them. Okay, so here's one way of solving a system of equations. We call it the graphing method. Basically, you're going to graph two equations. Here's our equations. They're already in slope-intercept form, so it'll be nice and easy to graph them. So, we're going to graph this equation first, and we're going to pretend it's the one in the roller coaster tracks in the foreground, okay? So, we already know it's at 10 because this is the y-intercept. Since it says it's 5x, that means that it has a slope of 5. So, if we graph that, it'll look something like this. Okay, this one's going to be our roller coaster tracks in the background. Since it has a slope of 2, we know it's going to be a lot less steep than this one. Since it has a y-intercept of 7, we can graph that. And it has a slope of 2, so we're going to graph it just like we graphed the other one. It's really simple to see exactly where these two meet up, which is right here, at -1, 5. This is called the point of interception. So, system of equations substitution method. This is going to be our roller coaster in the foreground, and this is going to be our roller coaster in the background. So, since these two are both equal to y, that means they should both equal the same things for this point. So, we do 5x plus 10 equals 2x plus 7. So, this is going to solve for the this is not going to solve for the y because there's no y in this equation. So, if we subtract the 2x, and we're going to subtract the 10, we get the solution 3 equals -3. So x equals -1. If we plug this back into one of our equations, y equals 2x plus 7, we get y equals -2 plus 7, or y equals 5. So it should be -1, 5. Also, the other one we can encounter is a slope-intercept and standard equation. So we're still going to put the y in at the y. So 2x minus 5x plus 10 equals -7. So we have to distribute the negative sign. So it's going to be just 2x minus 5x minus 10 equals -7. So if we simplify this equation, -3x equals 3, or x equals -1. We plug this back into this one. We get -1, 5. The third way we can solve a system of equations is called elimination. So, here's our system of equations, and we have to solve it. Remember, we're going to put it on an addition. We're going to set it up as an addition problem. However, we're going to try and get rid of all the y's so we can solve the x. Since they're both negative, it would just equal -2. If we multiply this one by -1 to get rid of this negative sign, we get 5x minus y equals -10, and -2x plus y equals 7. So, let's simplify this. 3x equals -3. Since it's a negative y and a positive y, they completely go away. We can easily see that x equals -1. If we plug this back into one of our equations, so -2 minus y equals -7, we get negative y equals negative 5. However, we need y to be positive, so y equals 5. So, it's negative 1, 5. Same answer as we got in the other two. Okay, now on to the most intimidating part of Algebra 1, quadratics. But it's okay, because it's also the best part of roller coasters. You know, the hills and the dips. And we can't get rid of those. So, guess quadratics will just have to stick around. Now, there's 3 ways that you'll see quadratics. Standard, vertex, and factored form. Okay, so first let's talk about standard equation. So standard equation is ax squared plus bx plus c equals y. But what do all those numbers mean? A is basically going to determine how wide your parabola is, and if it opens up or down. If A is negative, meaning it's below 0, then it's going to open downwards. If A is positive, meaning it's above 0, it's going to open upwards. B is going to determine whether the vertex falls exactly on the y-axis, or if it doesn't fall on the y-axis, which way it's going to fall, whether it's going to fall to the left of the y-axis or to the right. And C is the point at which it's going to intersect with the y-axis. And of course, y is the outcome. Next up, factored equation. So, the factored equation is y equals parentheses x minus h parentheses x minus k. This is really easy to find the x-intercepts. However, it's really difficult to find anything else. H and k are the x-intercepts, but for pretty much anything else, you're going to want to convert this equation into the standard form. Okay, last but certainly not least is vertex form, which is a pretty awesome and really useful form. It can be used to do a lot. Basically, it's y equals a parentheses x minus h end of parentheses squared plus k. H comma k is the vertex. Okay, so you can have 0, 1, or 2 real solutions. The way you discover how many solutions you have is by solving the discriminant. If you solve it and it's a negative number, then you're going to have no real solutions. If you solve it and it equals 0, you're going to have 1 real solution. If you solve it and it equals a positive number, you're going to have 2 real solutions. Okay, now we're going to find the solutions of a quadratic equation by graphing. So first, just to find out how many solutions we're going to have, we're going to find the discriminant. So there's no b, so we're going to do 0 squared minus 4, a is negative 2, and c is 2. So if we solve this, we get 0 minus negative 16. So since it's positive 16, we know we're going to have 2 solutions. So let's plug in the x variables into this equation to see what we get for y. So if we plug them in, we get negative 17, negative 6, 0, 0, 2, 0, negative 6, and negative 17. So if we graph this, we have negative 1, 0, 0, 2, 1, 0, 2, negative 6. So, we can easily see what the 2 solutions are, which are negative 1 and 1. We're going to write these in coordinate. Okay, now we're going to find the solutions using the quadratic formula. For the equation, negative 3x squared plus 3x plus 6 equals y. Remember, negative 3 is a, 3 is b, and 6 is c. So if we replace the numbers in for the letters, we should get -3 plus minus the square root of 3 squared minus 4, -3, 6. And if we solve over 2, -3. We're going to solve the part in the square root first, because that's the part that we should solve first according to the order of operations. So this equals 9 minus plus 71, 2 plus minus the square root of that, -3 over -6. So we should get -3 plus minus 9 over -6. Since it's plus and minus, we have to do both. So we have 6 over -6 and -12 over -6, which gives us -1 and 2. So our solutions are -1, 0, and 2, 0. Okay, now we're going to find the solutions using factoring. So, first we want to make sure one side equals 0 and all of the other numbers are on the other side, which this our equation already does. Second, we want to make sure that a is positive. So we're going to multiply the entire thing by a -1 to get 3x squared minus 3x minus 6 equals, it would be -0, but there's no such thing, so it's just going to be 0. So, first we want to put 2 x's because it's x squared. And then we're going to make a list of the factors of a and c. So 3 could be 1 and 3, or -1 and -3. And then for 6, it could be 1 and 6, -1. It could be 1 and -6, -1 and 6, 2 and -3, and -3 and 2. So we have many options, but we're going to go with first trying 1 and 3. So if you think logically, to try and get a -3, you would try and put 1 with 3 and 3 with 2. So this is going to be 6 and this is going to be 3. We want it to be negative, so we want the 6 to be negative, because -6 plus 3 equals -3. In order to get it to be -6, you put a negative sign in front of the 2. And this is possible because this number is -6, so one of its factors must be negative. So this is what the answer is. This is the two sets of factors. We're going to put them in parentheses. So it's going to be x minus 2 times 3x plus 3. So if we put the number in front of the x underneath the 2, and we want to change we're going to want to change the sign in front of the 2 because it's on the opposite side of the scale now. So it's going to be 2, and this is going to be -1. So, because we want this to be 0, so we're going to swap that out to the other side, and to find x, and we get -1. So, in terms, it would look like this. 3x plus 3 equals 0, but we want to find x, so if we subtract 3's, we get 3x equals -3, and we divide both by 3, we get x equals -1. So that's basically what's happening, and this is the outcome. So these are the two solutions. So we're going to write it in coordinates, 2, 0, and negative 1, 0. Okay, quick review. So, linear equations, there's 3 types. There's point-slope, slope-intercept, and standard. Also, there's system of equations, which is 2 overlapping linear equations when you're trying to find the point at which they overlap. So, there's 3 ways you can find that. Graphing, substitution, and elimination. And now, for everyone's favorite part of Algebra 1, quadratics. So, there's 3 types of quadratic equations. Standard, vertex, and factored. And then there's 3 ways you can find the solutions of a quadratic equation. There's graphing, quadratic formula, and factoring. This is all really important, but make sure the most important part of Algebra 1 is to always check your work. If you check your work, you'll do fine. That's all you really need to know for Algebra 1. So, hope you got it.